Haskell (Haskell) is a standardized, general-purpose, purely functional programming language, with non-strict semantics and strong static typing. It is named after logician Haskell Curry. History. Following the release of Miranda by Research Software Limited, in 1985, interest in lazy functional languages grew. By 1987, more than a dozen non-strict, purely functional programming languages existed. Of these, Miranda was the most widely used, but it was proprietary software. At the Conference on Functional Programming Languages and Computer Architecture in Portland, Oregon, a meeting was held during which participants formed a strong consensus that a committee should be formed to define an open standard for such languages. The committee's purpose was to consolidate the existing functional languages into a common one that would serve as a basis for future research in functional language design. Haskell 1.0 to 1.4. The first version of Haskell was defined in 1990. The committee's efforts resulted in a series of language definitions. Haskell 98 in late 1997, the series culminated in Haskell 98, and tended to specify a stable, minimal, portable version of the language and an accompanying standard library for teaching, and as a base for future extensions. The committee expressly welcomed the creation of extensions and variants of Haskell 98 via adding and incorporating experimental features. In February 1999, the Haskell 98 language standard was originally published as the Haskell 98 Report. In January 2003, a revised version was published as Haskell 98 Language and Libraries. The revised report. The language continues to evolve rapidly, with the Glasgow Haskell compiler implementation representing the current de facto standard. Haskell 2010. In early 2006, the process of defining a successor to the Haskell 98 standard, informally named Haskell Prime, began. This was intended to be an ongoing incremental process to revise the language definition, producing a new revision up to once per year. The first revision, named Haskell 2010, was announced in November 2009 and published in July 2010. Haskell 2010 adds the foreign function interface to Haskell, allowing for bindings to other programming languages, fixes some syntax issues and bans so-called N+K patterns, that is, definitions of the form fact equals * fact n are no longer allowed. It introduces the language pragma syntax extension, which allows for coder designating a Haskell source as Haskell 2010 or requiring certain extensions to the Haskell language. The names of the extensions introduced in Haskell 2010 are don't have an ELSA, hierarchical modules, empty data declarations, fixity resolution, foreign function interface, linear comment syntax, pattern guards, relaxed dependency analysis, language pragma and non-plusk patterns. Features. Haskell features lazy evaluation, pattern matching, list comprehension, type classes, and type polymorphism. It is a purely functional language, which means that in general, functions in Haskell do not have side effects. There is a distinct construct for representing side effects, orthogonal to the type of functions. A pure function may return a side effect which is subsequently executed, modeling the impure functions of other languages. Haskell has a strong, static type system based on Hindley-Milner type inference. Haskell's principal innovation in this area is to add type classes, which were originally conceived as a principled way to add overloading to the language, but have since found many more uses. The construct which represents side effects is an example of a monad. Monads are a general framework which can model different kinds of computation, including error handling, non-determinism, parsing, and software transactional memory. Monads are defined as ordinary data types, but Haskell provides some syntactic sugar for their use. The language has an open, published specification, and multiple implementations exist. The main implementation of Haskell (ghc) is both an interpreter and native code compiler that runs on most platforms. ghc is noted for its high-performance implementation of concurrency and parallelism, and for having a rich type system incorporating recent innovations such as generalized algebraic data types and type families. There is an active community around the language, and more than 5,400 third-party open-source libraries and tools are available in the online package repository Hackage. Code examples. The following is a Hello World program written in Haskell. Module main where main io factorial equals greater than or to a using recursion factorial n less than 2 equals 1 factorial n equals n asterisk factorial using recursion. With guards factorial n less than 2 equals 1, otherwise equals n asterisk factorial using recursion but written without pattern matching factorial n equals if n greater than 0 then n asterisk factorial else 1 using a list factorial n equals product 1 n using fold factorial n equals folder 1 n point freestyle factorial equals foldr 1. A num from to 1. An efficient implementation of the Fibonacci numbers as an infinite list is this. Type annotation fib into integer with self-referencing data fib n equals fibs n where fibs equals 0. Scan 1 fibs 0, 1, 1, 2, 3, 5. Same of coded directly fib n equals fibs n where fibs equals 0, 1. Next fibs next equals next t. Similar idea using zip with fib n equals fibs n where fibs equals 0, 1. Zip with fibs using a generator function fib n equals fibs n where fibs equals a. Fibs the int type refers to a machine-sized integer, while integer is an arbitrary precision integer. For example, using integer, the factorial code above easily computes factorial 100,000 as an incredibly large number of 456,574 digits, with no loss of precision. This is an implementation of an algorithm similar to quicksort over lists, in which the first element is taken as the pivot. Quicksort. Order equals greater than a 2. Quicksort equals the empty list is already sorted. Quicksort equals quicksort a less than xs. A less than x. Sort the left part of the list x insert pivot between two sorted parts. Quicksort a less than xs. A greater than equals x. Sort the right part of the list. Implementations. All listed implementations are distributed under open source licenses. The following implementations comply fully, or very nearly, with the Haskell 98 standard. The Glasgow Haskell compiler compiles to native code on a number of different architectures, as well as to ANSI C, using C as an intermediate language. ghc has become the de facto standard Haskell dialect. There are libraries that will work only with ghc. ghc is also distributed along with the Haskell platform. The Utrecht Haskell compiler is a Haskell implementation from Utrecht University. UHC supports almost all Haskell 98 features plus many experimental extensions. It is implemented using attribute grammars and is currently mainly used for research into generated type systems and language extensions. ghc is a Haskell compiler written by John Meacham emphasizing speed and efficiency of generated programs as well as exploration of new program transformations. ghc is a fork of ghc. LHC is a whole program optimizing backend for ghc. It is based on Herman Bergquist's compiler intermediate language, GRIN. Older versions of LHC were based on ghc rather than ghc. The following implementations are no longer being actively maintained. Hugs. The Haskell user's Gopher system is a bytecode interpreter. It used to be one of the most widely used implementations alongside the ghc compiler, but has now been mostly replaced by ghci. It also comes with a graphics library. nhc98 is another bytecode compiler. nhc98 focuses on minimizing memory usage. YHC, the York Haskell compiler, was a fork of nhc98, with the goals of being simpler, more portable and more efficient, and integrating support for HAT, the Haskell tracer. It also featured a JavaScript backend, allowing users to run Haskell programs in a web browser. HBC is an early implementation supporting Haskell 1.4. It was implemented by Lennart Augustsson in, and based on, LazyML. It has not been actively developed for some time. The following implementations are not fully Haskell 98 compliant, and use a language that is a variant of Haskell. Gopher was an educational dialect of Haskell, with a feature called constructor classes, developed by Mark Jones. It was supplanted by Hugs. Helium is a newer dialect of Haskell. The focus is on making it easy to learn by providing clearer error messages. It currently lacks full support for type classes, rendering it incompatible with many Haskell programs. Applications. Darx is a revision control system written in Haskell, with several innovative features. Cabal is a tool for building and packaging Haskell libraries and programs. Linspire, new Linux, chose Haskell for system tools development. Xmonad is a window manager for the X Windows system, written entirely in Haskell. GHC is also often a testbed for advanced functional programming features and optimizations in other programming languages. Industry. Facebook implements its anti-spam programs in Haskell. BlueSpec System. Verilog is a language for semiconductor design that is an extension of Haskell. Additionally, BlueSpec Inc.'s tools are implemented in Haskell. Cryptol, a language and toolchain for developing and verifying cryptographic algorithms, is implemented in Haskell. The first formally verified microkernel, Self-OR, used Haskell as a prototyping language for the OS developer. At the same time, the Haskell code defined an executable specification with which to reason, for automatic translation by the theorem-proving tool. The Haskell code thus served as an intermediate prototype before final C refinement. Web. There are Haskell web frameworks, such as Yesod, Hapstack, Snap. Criticism. Jan Willem Mason, in 2002, and Simon Peyton Jones, in 2003, discussed problems associated with lazy evaluation while also acknowledging the theoretical motivation for it. In addition to purely practical considerations such as improved performance, they note that, in addition to adding some performance overhead, lazy evaluation makes it more difficult for programmers to reason about the performance of their code. Bastiaan Hiran, Daan Lijen, and Arjen van Ijesendorn in 2003 also observed some stumbling blocks for Haskell learners. The subtle syntax and sophisticated type system of Haskell are a double-edged sword, highly appreciated by experienced programmers but also a source of frustration among beginners, since the generality of Haskell often leads to cryptic error messages. To address these, researchers from Utrecht University developed an advanced interpreter called Helium, which improved the user-friendliness of error messages by limiting the generality of some Haskell features, and in particular removing support for type classes. Ben Littmeyer designed Disciple as a strict by default dialect of Haskell with a type and effect system. To address Haskell's difficulties in reasoning about lazy evaluation and in using traditional data structures such as mutable arrays, he argues that destructive update furnishes the programmer with two important and powerful tools: a set of efficient array-like data structures for managing collections of objects, and the ability to broadcast a new value to all parts of a program with minimal burden on the programmer. Robert Harper, one of the authors of Standard ML, has given his reasons for not using Haskell to teach introductory programming. Among these are the difficulty of reasoning about resource usage with non-strict evaluation, that lazy evaluation complicates the definition of data types and inductive reasoning, and the inferiority of Haskell's class system compared to ML's module system. Related languages. Clean is a close, slightly older relative of Haskell. Its biggest deviation from Haskell is in the use of uniqueness types instead of monads for I/O and side effects. A series of languages inspired by Haskell, but with different type systems, have been developed, including AGDA, a functional language with dependent types. Idris, a general-purpose functional language with dependent types, developed at the University of St. Andrews. Epigram, a functional language with dependent types suitable for proving properties of programs. KN, with dependent types. Omega, strict and more. Elm, a functional language to create web front-end apps, no support for higher-kinded types. JVM-based. Frege, a Haskell-like language with Java's scalar types and good Java integration. Haskell, a functional scripting programming language that runs in Java VM. Other related languages include Curry, a functional logic programming language based on Haskell. Haskell has served as a testbed for many new ideas in language design. There have been a wide number of Haskell variants produced, exploring new language ideas, including Parallel Haskell, from Glasgow University, supports clusters of machines or single multiprocessors. Also within Haskell is support for symmetric multiprocessor parallelism, from MIT. Distributed Haskell and Eden. Eager Haskell, based on speculative evaluation. Several object-oriented versions. Haskell++ and Mondrian. Generic Haskell, a version of Haskell with type system support for generic programming. ʻhæskəl, an extension of Haskell adding object orientation and concurrent programming support which has been superseded by Timber. Disciple, a strict by default dialect of Haskell which supports destructive update, computational effects, type-directed field projections and allied functional goodness. Scotch, a kind of hybrid of Haskell and Python. Hume, a strict functional programming language for embedded systems based on processes as stateless automata over a sort of tuples of single element. Mailbox channels where the state is kept by feedback into the mailboxes, and a mapping description from outputs to channels as box wiring, with a Haskell-like expression language and syntax. Conferences and workshops. The Haskell community meets regularly for research and development activities. The primary events are International Conference on Functional Programming, Haskell Symposium, Haskell Implementers Workshop, Commercial Uses of Functional Programming. Since 2006, there have been a series of organized hackathons, the HAC series aimed at improving the programming language tools and libraries. Since 2005, a growing number of Haskell users groups have formed.